Hello everyone. In this video, we will be covering a few more formulas which was very helpful in cracking CAT, XAT and IFT question in the previous years. For example, if you see A minus B is equal to A minus B. A square minus B square is equal to A minus B, new bracket A plus B. One more example, A cube minus B cube is equal to A minus B within bracket A square plus AB plus B square. Now look at these three formulas and you will understand what is happening. So if we have something like A ka power n minus B raised to the power n, so it will always have one bracket starting with A minus B. As you can see in the three different identities, this is A to the power 1 minus B to the power 1, which is obviously equal to A minus B. Now it is A square minus B square. There is a bracket of A minus B coupled with a bracket of A plus B. Again, when AQ minus BQ, it is A minus B and then A square plus AB plus B square. So we can generalize that A to the power n minus B to the power n is equal to A minus B within bracket A square plus there are many terms. What we have to remember for the exam is that it starts with the power of A, which is 1 less than the power of A here. For example, if I have to factorize A to the power 101 minus B to the power 101, what remains outside is A minus B, and within bracket you have a term A to the power 100 plus there will be many terms which is not the part of the syllabus. Those terms are not important for you as of now, but you need to remember that it ends with B to the power 100. That's all. So this is where you need to understand this formula. And if you understand this formula, you will understand two things. One is that A to the power n minus B to the power n is always divisible by A minus B. So you may say that A to the power n minus B to the power n when divided by A minus B, the quotient is A to the power n minus 1 plus different terms plus B to the power n minus 1. If you put the value of n is equal to 3, let's see what happens. This becomes A cube minus B cube divided by A minus B, which is equal to A square plus AB plus B square, which is a mandatory formula for you. If you put n is equal to 2, what happens? A square minus B square divided by A minus B is equal to A plus B. Now, there are many facts hidden in it. You have to memorize three facts. Number one, that A to the power n minus B to the power n, when factorized, will always have a bracket A minus B and then again a bracket. So this is always divisible by A minus B. This is always divisible by A minus B irrespective of the value of n. And the second thing, when n is even, for example, n to the power, for example, n to the power 4 minus b to the power 4. Now what is this? This is a square to the power square minus b square to the power square, which is again a square minus b square into a square plus b square. So when you take this common, when you factorize this, it becomes a minus b into a plus b into a square plus b square. Look at the power of a in all the three brackets. The power of a is 1 here, and 2 here, right? So when you add them up, it will be equal to 4. Now, any even power, a to the power 2n minus b to the power 2n, that is even power, it will be written in the form of a square to the power n minus b square to the power n. And then again, it will be like a square minus b square. And then you will have a bracket a square to the power n minus 1 plus dot 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 plus b square to the power n minus 1, like this. So what do you see here? You see that a to the power n minus b to the power n is always divisible by a minus b. And when n is even, it will also be divisible by a plus b. So these two formulas are very, very masoom formula, but you need to memorize this. Okay. So all those calculation and derivation I was showing for simple purpose that you memorize formula number 2, formula number 3, and if possible, you also memorize this. So ultimate purpose was formula number 2, formula number 3, and formula number 4. Do you want to revise it once? Watch the video again. So ultimate formula a to the power n minus b to the power n by a minus b will be a to the power n minus 1 plus there are many terms which is not of our interest, b to the power n minus 1. This is what I want you to memorize. Okay, now one more thing. Look at this, a plus b is equal to a plus b. Look at this, a square plus b square. No formula. Look at this, a cube plus b cube is equal to a plus b within bracket a square minus ab plus b square. Look at this, a ka power 4 plus b raised to power 4 is equal to no formula. Look at this. The most of you will say that, sir, please repeat. Look at the first formula, a to the power 1 plus b to the power 1. Now what is happening? It is equal to a plus b, obviously. The second formula does not have any such identity, no formula at all. The third one, a cube plus b cube, will have a factor a plus b and then the quotient. The fourth one does not have any formula. The fifth one again. So if somebody confirms that n is even, if n is even, then only you can factorize a to the power n plus b to the power n. When n is even, you can factorize this as it, right? A plus b, sorry, when n is odd. Only when n is odd, you can factorize this. When n is odd, you can see this, right? A to the n minus 1 plus minus dot dot dot. The last one will be dependent. This is plus sign, okay, and this is cube, third. So will it be always plus sign? Okay, it is always plus sign. B n minus 1. So when n is odd, you can break this, and this is for all when n is even or odd. Now take one simple example to understand this type of question. This is CAT 2004 question where 15 to the power 23 plus 23 to the power 23 is divided by 19. Now look at this, a to the power n plus b to the power n. First confirm whether n is odd or not. So here n is equal to 23, which is odd. So when n is odd, a to the power n plus b raised to the power n is divisible by a plus b. This is possible because the power is odd. Now a plus b is 38. So this number is actually divisible by 38. Okay, divisible by 38. Now 38 is a multiple of 19. So if a number is divisible by 38, it will be divisible by 19. So there will be no remainder. Remainder will be 0. The remainder is going to be 0. One more question from GMAT. N is equal to 3 to the power 8 minus 2 to the power 8. Now, the power is even. Okay. Now, you can write it 3 to the power 4 to the power 2 minus 2 to the power 4 whole to the power 2. So, 3 to the power 4 is 81. 2 to the power 4 is 16. Okay. So, N is equal to 81 square minus 16 square. Now, which is equal to 81 plus 16 into 81 minus 16. Now, we are not supposed to apply any formula because directly we can solve. 81 plus 16 is 97 and 81 minus 16 is 65, right? So, the question asks you which of the following is not a factor of n. So, 97 and 65 is already a factor of it, right? Now, if 3 to the power 8 is written as 3 square to the power 4th power and 2 square 4th power. So what happens? This is equal to 9 raised to the power 4 minus 4 to the power 4. Now again, the power is even. Remember the formula a to the power n minus b to the power n, which is always divisible by a minus b and is divisible by a plus b if n is even. A to the power n minus b to the power n is always divisible by a minus b and is divisible by a plus b if n is even. So n is even here, 4 is even here, right? So what will happen? It is divisible by 9 plus 4, which is 13, and 9 minus 4, which is 5. So 13 and 5 are also multiples, also factors. 13 and 5. So what is not a factor is 35. This question though has appeared in GMAT but has been asked in many different exams in the previous year in different format. A very famous question. A to the power 6 minus b to the power 6. Now it can be written as a cube whole square minus b cube whole square, which can be written as a cube plus b cube within bracket a cube minus b cube. So a cube minus b cube and a cube plus b cube. These are the two factors of this number. Quite easy to conclude, right? But there is another aspect. Look at it closely. The same number it can be written as a square cube minus b square cube. Now, what is the formula for a cube minus b cube? The formula for a cube minus b cube is a minus b. A minus b. So what is a here? A is a square. So a minus b. And within bracket, what is the formula? A square plus ab plus b square. So a square means a square whole square plus ab, that means a square b square, plus b square, that means b square whole square. So basically we have assumed a square to be a and b square to be b. Now a cube minus b cube is a minus b, a square plus ab plus b square, which is b to the power 4. Okay. Now what will happen? This a square minus b square can be further factorized as a minus b, a plus b, and what remains inside the bracket is a to the power 4 plus a square b square plus b to the power 4. Now, this is your a minus b here, one of the factors, a plus b here, another factor, a4 plus a square b square plus b4, another factor, and then you can see a square minus b square is obviously a factor. So factor, 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 factor. So 1, 2, 3, 4, 5, 6 factors. These two are not the factors, like a square plus b square is not a factor and a4 minus b4 is not a factor. Okay, so this question did not come in an exam, but the concept is very, very important. A to the power 6 minus b to the power 6. Now 6 is a composite number. Sometimes you may write it 2 into 3 and sometimes 3 into 2. Now take this question. 16 cube plus 17 cube plus 18 cube plus 19 cube. And you have to find the remainder when this number is divided by 70. Right? So we have to apply some technique like 16 cube plus 19 cube, take one side, 17 cube plus 18 cube on another side. Okay, now a to the power n plus b to the power n is what? Is a multiple of a plus b. So this area is a multiple of a plus b. Now this area is also a multiple of a plus b because power is odd. Okay. So I have divided the question into two parts. First part is 16 cube plus 19 cube. I did not take 16 plus 17. Because if I take 16 plus 17, the sum will be equal to 33. And 18 plus 19, the sum will be 37, which will not serve my purpose. Because I have to ultimately calculate the remainder after dividing by 70. 70 is a multiple of 35. I can see that 16 plus 19 is 35 and 17 plus 18 is 35. And the formula tells me that a cube plus b cube has definitely a factor a plus b. We have a very simple formula. You know that formula. A cube plus b cube is equal to a plus b within bracket a square minus ab plus b square. So in that formula, what is that a plus b? That is nothing but the factorize. When you write a cube plus b cube is equal to a plus b within bracket a square minus ab plus b square. So you may safely say that a plus b is a factor of this and a square minus ab plus b square is a factor of this. You can safely say. So applying the same logic, 16 cube plus 19 cube is a multiple of 16 plus 19, which is nothing but 35. Now 17 cube plus 18 cube is nothing but as a multiple of 17 plus 18, which is nothing but 35 ka multiple. So basically the entire expression is a multiple of 35. The entire expression is a multiple of 35. Okay, first you need to be convinced by this, that the entire expression is multiple of 35. Now 35 multiples. I will write a few 35 multiples. I am writing a few multiples of 35. What happens when you divide the first number by 70? What happens when you divide the second number by 70? Third number by 70? Fourth number by 70? Fifth number by 70? Sixth number by 70? What happens? If you divide the first number by 70, you get remainder as 35. If you divide the second number by 70, you get the remainder as 0. If you divide the third number by 70, remainder is 35. If you divide the fourth number by 70, remainder is again 0. So what is happening? Because if it is a odd multiple of 35, Odd multiple means 35 multiplied by 1 or 3 or 5 or 7. So if it is an odd multiple of 35, when it is divided by 70, the remainder remains as 35. And when it is an even multiple of 35, even multiple means 35 into 2, 35 into 4, 35 into 6, and so on. So if it is an even multiple of 35, when you divide that particular number by 70, for example, 70 itself, 140, 210, 700, 560, there's so many examples, remainder will be 0. Now, your job is to find out whether the entire expression is an even multiple of 35 or odd multiple of 35. Very, very easy to find out. You have to find out whether the number is an even or odd. Very simple. If you can conclude that the number above number is an odd number, the answer will be 35. And if you conclude that the above number is an even number, the answer will be 0. So let us check whether 16 cube, 17 cube, 18 cube, 19 cube. 16 cube means 16 into 16 into 16, even. 17 cube means 17 into 17 into 17. So that cannot be even, it will be odd. Similarly, this will be even. Similarly, this will be odd. There are two even numbers. So even plus even, this will be even. Two odd number, odd plus odd, this will be even. When you add two odd number, it becomes even. Now even plus even, even. So the above expression is an even number. It is an even number and it is a multiple of 35. So try to find out an even number which is a multiple of 35. Try to find out an even number which is a multiple of 35. You will find that it is also a multiple of 70. So this number is actually a multiple of 70. So when that number is a multiple of 70, your answer is 0, because when you divide this by 70, the answer is 0.